clearly, I'm very impressed, especially with the amount of Guinness that was around last night, and I've indulged, so please forgive any slightly hangover vibes. I am so excited to be here this morning with Cassie. We've spent a little time talking, and I think you're in for a treat, because what she has done with me is to completely open up my mind to a new way of thinking about data. I work for the BBC, and like many of you in this room, we use data in so many ways, and we talk about it all the time, and we think about it all the time, and we've got sucked into this great new way of thinking about data being the thing that's going to drive our business for the next forever. We've got so obsessed with it. But what Cassie's made me think about is that we might not be obsessed with it in the right way. So we're going to have a chat now for about 40 minutes, and we're going to go into some of the fascinating things that I've learned from just preliminary conversations with Cassie. And what I'd like to start with, Cassie, as you may know, works for Google as a chief decision scientist. And this, to me, was a really interesting piece of catnip. What is a decision scientist? We're going to find out. But let's just start with a question about data. Do you think we think too much about data and not enough about how we make the decisions that we need to make about how we use it?
Absolutely. So I remember from our conversation yesterday, you were telling me that when you asked your colleagues what data is to them, that their answer was that it's numbers. And I don't know if everyone will be surprised, but to me, that is not what data is. Two ways that I think about data. One is that data is memories. Data is some stuff that we humans decided to capture from reality. And we don't have the ability to capture reality in its fullest, not even with our technology, not with our senses. So it's just going to be a small piece of reality. And in order to choose to capture that reality, we have to find it important. So let's suppose I decided to capture some data about the people here. Maybe I would find important how many people were here. And then you were to ask me some other question. You were to ask me how many people were wearing white shirts. If that's not what I found important at the time, and if I didn't capture the data in the right way to give me that information is gone, that memory is gone. Now, the second way that I think about data that's really close, I think, to your heart, is when I say capturing the data, really, data is what we've chosen to write down. Data is an extension of writing. So when I talk about the history of data science started with writing. It started when thousands of years ago, a bunch of merchants said, we will find it much easier to figure out who owes what to whom if we have a writing system with clay tablets. And we have been evolving that system to be more efficient and better at storing information. Because if you think about, you went from the tablet, eventually you went to the quill and the manuscripts, the printing press. Now you've still got a book, a paper book, and you want to say, abracadabra book, how many A's are in this book? Well, how are you going to have to do that? You have to read the whole book. You have to store all the information. Your memory can't handle it. Now with the computer, same thing written down, just much more convenient to interact with that information. Now you can, with a little line of code, abracadabra, how many A's are in this book? How many A's in Wikipedia? From a photograph, abracadabra, how many people maybe were wearing white shirts, if that photo was well taken. But it is all just writing. And so with writing, there are different qualities of writing, as we discussed, and there are different uses for writing. And so if we over-focus on the fact that we have a piece of writing, and we don't ask what is it for, and who made it, and who wrote it, and with what expertise, and why should we even read it, I think then we're missing all the main points. So with data, I like to say, if a data point or an opinion falls in a forest and nothing changes from it, if it doesn't turn into an action, what's the point of it? Data, just some memories, just some stuff we wrote down that might be a means to an end, if we use it cleverly, if the data are good. So what I want to encourage everyone to do is to stop pronouncing data like it's something special, like it's something new, like it has a capital D in it. It's a more convenient technological extension of what we've been doing this whole time, writing, improving our memories. But it's not something magical. Just because someone wrote something down doesn't make it true, doesn't make it good, and it doesn't make it useful. That's up to us. That's up to what we need it for, and it's up to us to be smart about using it for good and useful things, for decisions.
So let's move on to that, because I think it got its capital D when we started to get all these wonderful computers. And I don't know about you guys, but I find that we tend to, in our organization, really sort of glue together data, machine learning, AI, and statistics. We
And
stick them
analytics.
together. Yeah, and what, sorry?
And analytics.
And
We should
analytics.
never forget analytics.
And never forget analytics. And we stick them together and we sort of go, right, we've got a data and AI thing going on here. And I think that some of the incredible things that have happened with things like machine learning, so, you know, when you can throw a whole load of data at a machine and say, you know, here's a load of medical images, can the machines spot, you know, where the cancer is? And we found that the machines sometimes can do that better than humans. I think we've, to an extent, got a bit overexcited about that. And we've started to think, the data's there, it's there, all we need to do is just kind of find ways to wrangle it. Cassie mentioned in one of the podcasts, which I highly commend to you, that she's created, something about us as a tool-making species. Do you think that perhaps the use that we make of the tools that we've created is still a bit clumsy? And if so, how can we be more elegant with these tools that we're starting to create to interrogate data? And we're going to come back to making sure the data's right. But what about our tool-making skills in this field? Are we doing the right things?
Oh, well, there is so much to talk about with respect to tool making. So first, I do like thinking about all this stuff as a means to an end. So if we're thinking about writing as a tool for improving our memories, we're thinking about data and the different formats that we might capture and store data in as an improvement over writing. And imagine how long you would have to write to describe an image, and how would you even write to describe a scent, right? That would be difficult unless you had, as perfumers do, coded up all the different names for things and learned them and understood them. Maybe you could write it, but there are much more efficient ways to go about storing and presenting and manipulating information. So as we develop those ways, those are tools that extend our ability to remember, think, and understand. But what we're not doing enough of is thinking about the usability of those tools. So what I find quite funny in data science, which is the discipline of making data useful, so anything under the umbrella of taking data and turning it into something good kind of falls under data science. So we're going to include analytics, statistics, machine learning, AI under that. Now, traditionally, poor data scientists had to go and fight these battles, wrangle these really miserable tools to make incremental progress. But they would end up having to do it the hard way. And somehow to be part of our community, you know, you have to embrace like, oh, I'm this hardcore person. I'm going to write code to do everything the difficult way, I guess. You know, then the expectation is maybe you'll get paid a whole lot because very few people can do it. And the tools behind data science are improving, but not fast enough, because we're not really embracing the idea that some of what's going on is hard because it's intellectually hard, and that is thinking about information and how you might turn the information into better action. In the same way as writing well is hard, not for reasons of how clunky your typewriter is, or you know, how good the ink on your quill is, or those clay tablets, but writing well has this intellectual component that, you know, I don't know that there's a tool that's going to automate that away. And then there's the other piece where it's hard just because the tools are rubbish. Like, as we go from a clunky typewriter or clay tablets, even worse, to now anyone can open a Word document on a nice laptop with easy keys, and then off you go. Data science and data tools are much closer to the clay tablets than to the quick Word document experience. And that does not need to be the case. We should embrace and lean into making better tools. There are a lot of organizations that are trying. Google's one of them. But if only we just really embraced this more. We could do so much more with information.
You speak a lot about going from that kind of academic, let's make these tools and let's create them and let's create the algorithms to how we apply it. And that's, I think, where we're both really interested. It's how we get that incredible science out into our businesses to make a difference there. Do you think we think enough about the teams that we deploy to do this? Because we're very focused on data scientists, really difficult to get, really expensive sometimes, really brilliant. I went to the BBC in case they're listening. Do we focus enough about the wider teams and making those teams multidisciplinary enough to really deliver us results?
We need to focus on that. Of course we don't. Of course we don't focus on that. We've got far too much magical thinking when it comes to data. We pronounced data. I should stop saying we do. I hope we don't. Let's all stop. If you don't do it anymore. We need less magical thinking in the space of data. Less pronouncing it with a capital D. Less thinking, you just sprinkle some data over the top of your project. Everything is great. And less thinking that by hiring a data scientist, you've hired some all-powerful wizard that can just fix your project. The data piece is a small piece in the middle of a much larger end-to-end process. And so when you have experts who can do the middle bit, and you haven't worried at all about the people at the front and at the end of it, it's going to go nowhere. You're building essentially like a bridge that starts in the middle of the ocean and it ends in the middle of the ocean, and you're going to get nothing out of it. And all of your data endeavors should start with the actions, the real-world actions, that your endeavor might impact. That means that data must start with the decision maker. And it must start with the actions. But that's not the only person on the team. Then once we have what kind of thing we might like to do with the information, we might end up having a really large team of supporting characters. Like, let's suppose we're going to build an AI system that has the potential to impact a lot of lives. I really want to see an ethicist on that team. Right? We have potential to impact a lot of lives. Should we do that? Maybe somebody who's qualified to think about that should be included in the conversation. I rather insist, personally, that should be the case. Then let's suppose that we are building an AI system that should delight users and be fun for them to interact with online. Maybe we need somebody who knows what users want and are delighted by, so now we need user experience designers as part of that. Maybe it's going to involve lots and lots of data that needs to be moved from place to place. Who's going to collect that data? We need someone to do that. Who's going to actually build the pipelines? That's a data engineer. We might need software engineers. We'll need reliability engineers to keep that system working well. We'll need statisticians to test it. We'll need product managers, product experts, program managers. We'll need a whole cast of characters that changes from project to project. And what scares me a little in the AI setting is that there are two attitudes that I really don't like there. Newly minted AI folk who have a PhD specifically in AI research, they sometimes insist on carrying the whole thing themselves without maybe realizing that you are what you spend your time on. So if what you've spent your time on is learning to be a brilliant writer, that is what you are most likely to be good at. If you've spent your time on creating AI algorithms, that is what you're most likely to be good at. And you're not necessarily going to be good at any other piece of this process. So understanding that it's a team sport and seeking collaborators who can do the bits that are not your forte, not your major, that's really important in success. Now, the bit that scares me is that I've seen AI folk be dismissive of anyone who is not simultaneously a graduate-level AI expert. And I remember being at a conference in London and speaking with a fellow who had joint PhDs in philosophy and ethics and computer science, saying the reason that he felt listened to in philosophy, which was his area, is that he also had the computer science PhD. That is a mistake. If you're only going to accept people into a community who are jointly, doubly overskilled in something, your community is going to be really small. And you're not going to get the expertise. So I think we need to be more welcoming. There are a lot of different people who can contribute in wonderful ways to a project that is definitely a team sport, that requires a diversity of skills and perspectives. And we really, really need to embrace that more. That's thing one. The other thing is, remember when I said that for data, someone has to collect it? We don't have a title for that person. With AI, with data anything, right? Data is memories, stuff people wrote down. If they wrote down some rubbish, you're going to have bad results. Garbage in, garbage out. We hear that all the time. And yet, what is the job title throughout the industry that is accepted as the expert in making sure that the stuff that comes in is not garbage? There's no title like that. When I ask a bunch of different people, who in your organization does this? I ask them first, what's your title? They'll answer X. Then I'll say, who in your organization is responsible for data quality? They'll say, mostly X. That should worry you. If we are trying to build beautiful things with data, we need people who are skilled as experts specifically in designing data collection. So that, I think, is a huge area for improvement.
It's a really good point, isn't it? And I think, we're at a stage of evolution where you use the word magic. I think far too many people in certainly my organization see it as something that happens over there. It's those magical people who are kind of doing things with AI, with machine learning. And I can't get involved because I don't understand it. I did a course in machine learning, and I learned how to make those beautiful charts. We were talking last night, and Cassie said to me, the trouble is with some people is they learn how to make a beautiful chart and they think they're doing ML, so there we go. That was me. I now know that I'm not going to be one of those experts, but what I'm learning is that we need to build these much more multidisciplinary teams and also demystify in the rest of the organization, get people to ask those questions. How do we know the data's right? How do we know it's good? How are we checking that? Because I think one of the things that you say is about assumptions, and it's about the assumptions we make. We're going to move into the decision-making area now. So tell us a bit about the assumptions that we sometimes make, probably wrongly, with the data that we're using quite often to lead us to quite important decisions.
Oh, the assumptions piece is such a large piece of this. But always remember that whatever data that you've collected, it is always an impoverished view of reality. It's not reality. It's not everything that actually happened and is relevant. And so as you're looking at it, chances are there's something missing. And you want to jump from this thing to something bigger. The jump of going from what you have to what you wish you had and understood, that jump always involves assumptions of various kinds. And there are really basic assumptions also, like the data that I'm looking at is actually correct. It is what it says it is. There are assumptions to do with its appropriateness. There are assumptions to do with the data from the past still applies to the future. We're actually making that assumption all the time. But if your world changes, the rug is pulled out from under you, maybe some kind of coronavirus strikes all of a sudden, then your past data will have nothing to do with your future reality. And that assumption will be incorrect. Now, unfortunately, when making decisions with data, we are always taking our data plus some assumptions and doing our best with the combination of the two. So your conclusion, your action, your decision is going to be, if you do everything correctly, is going to be right for your assumptions. But your assumptions are also a cartoon of reality. So your data scientific conclusion is going to be right subject to some assumptions, which are probably wrong, but they may or may not be useful. And if you treat that result as truth, you have really missed a few steps here. What you're really doing is you're saying, here's what I know, here's some things I'm willing to assume, here's what's reasonable based on that. If I change what I'm willing to assume, something else might be reasonable. So when we talk about data, when we talk about facts, and we don't own up to ourselves and to the people that we're talking to about what assumptions are there, most of the conversation is missing.
So let's recap and see where we've got so far. We've got to make sure the data's right. We've got to make sure that we've got mechanisms in place and perhaps even jobs in place that are responsible for making sure that the data we're using is accurate, responsible, and reliable, and to identify our own assumptions. Let's move on now to those actual decisions, because I think this is a really important area. I think sometimes we think, don't we, that once we've got the data, however good it is, to our satisfaction, it will then lead us to a decision. But we're missing a step, aren't we? Because there is a kind of a science around decision-making in which you're an expert. I know the answer is going to be no to this. Okay, so how could we get the people who are working in organizations better to understand and better able to use the data they've got to make those decisions? So at the point of decision-making, what are we missing in terms of understanding, training, and just being aware of the things that come into play when we're making those very key decisions sometimes for our organizations?
Oh, this is such a big area. I mean, this has been my passion since I was quite young, so I could speak for several decades. Hard to choose where to begin. And the first thing that I'll say is that decision-making is a skill. And it is something that you can practice and learn and get better at. And there are vast swaths of literature that will point you in better directions. Unfortunately, there's not a stitched together single discipline that is readily going to give you all the components that you need. We're trying to put one together and call that decision intelligence. But right now, if you're going to learn to improve your decision skills, you're going to have to go over here to economics and read some, here to philosophy, the managerial sciences, the data sciences, psychology, neuroscience, take these things and try to improve your decision skills. And you should, if you are interested in participating in data and participating in decision-making, you should build your skills up. What we need to understand is that things must start with the decision maker. It doesn't make sense if you start anywhere else unless what you're doing is analytics. Now, what is analytics? Analytics is the art of, with an open mind, having a look and getting inspired. And you could have a look at things just with your human senses. I am looking at a bunch of data right now, and maybe I'm getting inspired. Like, I might look out onto this audience, and if there was no one sitting there, I might be inspired to to stop chatting if there's no one here, right? That's looking and potentially thinking about courses of action that I hadn't thought about before, based on what's there. We do that with data all the time. We have no idea what decisions we want to make. We have no idea what questions we want to ask. The best place to start is go have a look at some things. And look at the data in the electronic form. Look at data in the real world. Again, I don't like to make the distinction between data as some electronic stuff that we wrote down and the data coming in through our senses, having conversations. It's also data. So when you're doing analytics, you're doing that too. You're looking at what's here. You're getting inspired. And you can do that before you know what you want with it. Any other kind of data project or data approach needs to start with the decision. What decisions are we going to make and how? And to do that, again, you have to have a bunch of training. I'll take as an example your Statistics 101 class, if you've taken a Statistics 101 class in college. In your Statistics 101 class, chances are that it looks like it starts with a pair of hypotheses, a null and an alternative. Where do those hypotheses come from? They actually come from something called a default action. That is a choice by a decision maker, which your professor is quietly doing in the background. You don't even notice. The default action is what would you like to do by default without any additional information. That is a decision skill. Somebody has to take responsibility for saying something like, here is a potential new pharmaceutical. My default action is not releasing it unless it is better than what is already available. You could have a different default action. I don't recommend this one of saying we'll release it no matter what and convince us not to. But the framing of what you're going to do without any further information, right, that's already a major step. Somebody has to take responsibility for that. Then you go from that major step to what would it take to convince you? Like the big question that you need to start asking in your organizations to really put a focus on decision-making is, what would it take to change your mind? That means understanding what your mind is already set to and acknowledging what information it would take and in what form should that information come to be convincing enough to change your mind. And that is not something you learn in data classes.
So this is a bit of a revelation to me, and maybe this is just me in my organization, but that feels so familiar. That feeling of kind of, we've done some audience research, they've told us this, but sheesh, that isn't what we want to do. You know, so what can we take out of that research that does back up what we do? And I feel so kind of like, I feel guilty about that now, because you know, the clear thinking that you get from actually deciding how open-minded you want to be is really, really important, isn't it, from what you're saying? And it's really necessary to understand what directions you might take if the data that you're going to genuinely bring in, hopefully, you know, if it's the right sort of data, with what it's going to tell you. I asked my colleagues what questions they wanted me to ask Cassie today, and the question that came out top of the list was, what do you think about the thinking around explainable AI? A big obsession with many of us who are working with machine learning and data at the moment. This kind of need to explain to people who are affected by the data that we're using and the data that we're processing, what we're doing with it and why and what impact that might have. Now, I know you have particular views on this, so hit me with them.
So many views. I'm going to have to, there are going to be two chains, and I'm probably going to lose the plot because I'm going to have to develop some complicated arguments. So I'll ask you to bring me back to analytics versus XAI when I forget what thing I was going to say next. The first thing, though, is let's go back to why there'll be a question or problem of explainability with AI in the first place. And for that, we need to ask, what is AI? What is it for? AI, I kind of wish that we hadn't called it artificial intelligence, because that makes us think of personhood, and then we get all these unnecessary sci-fi perspectives from the uninitiated. I wish we had called it something like software 2.0. AI and machine learning are just a different way to program computers. How do we program computers traditionally? A computer takes an input, turns it into an output. It's approximately what it's for. Put something in, get something out. And there's something in the middle there that decides what to do with that input to turn it into the output. That piece in the middle in traditional programming, that model or recipe, that is a set of instructions written as code that a developer has to think up. They have to understand what the task is and how to do it. Then they have to think up and hand-stitch those instructions. Machine learning and AI are a different way to get the instructions in the middle. Instead of explaining exactly what the machine has to do step by step, the way you program is you say, here are a bunch of examples. Now figure it out. And we as humans, we already, if we want to teach one another to do a task, we have these two modes of communication already, right? I could tell you exactly the instructions for any little thing that I wanted to teach you. You know, if I wanted you to identify the right way to approach a problem, I would say, first you do this, then you do that, then you do that. Or I could say, watch me do a few of them. Then you can find the patterns among what I'm doing. You can learn from those patterns the way to do it next yourself. That is the essence of machine learning, just a different place that the model, the recipe that converts the inputs to outputs, comes from a different place, not from instructions, but from examples. That's it. That's all there is to it. Now, why would we do that? Here's the question. If I could give explicit, perfect instructions for how to do the task, why would I mess around with giving examples, right? That's removed. That's one step over from where I'm trying to go. If the task is as simple as, you know, move 2 beads on the abacus, then move another 2 beads on the abacus, then count 1, 2, 3, 4, right? Why on earth would I be trying to teach you this with patterns and examples? No, just write what you want and be done with it. So under what circumstance are you going to start doing this examples thing? When the examples are really easy to come up with, but the instructions aren't. It's when you're just thinking, oh, what would be the right instructions if I wanted to explain to someone how to take, say, a photo of a cat, and then what should I do with every individual pixel in this photo to identify if it is or is not a cat, right? Can you tell me what should be done with each pixel? It's hard for you to come up with that recipe yourself. But it's really easy for you to say whether something is or is not a cat. So you give up on trying to come up with the recipe. Instead, you give a bunch of examples. Here's a bunch of cats, here's a bunch of not cats, you figure it out. Now, the point is, this happened because you could not come up with the recipe yourself. This is what I keep coming around to. What kind of recipe can you not come up with yourself? The one that is way too complicated to hold in your brain. It's too convoluted, too difficult. And so now, when you are trying to use AI, you are essentially automating the ineffable. You're saying, damn it, I cannot express this, therefore I'm going to try with examples. And then you say, but how do I know if I can trust the results? How do I know if I can trust the recipe? And your mistake would be to expect that you could just open it up and you can read it and see how it works. The very point of doing this was that you could not read it to find out how it works. It's too complicated. So now you start reading it, it's millions of lines of gibberish. You are 5 lines in, you've already forgotten the first one. Reading it doesn't help you. That's not how you're going to know if it works. You're going to know if it works by testing it. That's not explainable AI. That's good testing. So people who want explainable AI as a source of trust, that's the wrong approach. I want you to imagine you can fly in 2 spaceships. One of them, you've got all the explanations of all the physics of how it works, but you've never flown it. No one has ever flown in it, but you can read all the physics. Here, I'm going to give you 10 million pages of physics. You read, then you decide if you want to go in the spaceship. And for the other one, I can't tell you at all how it works. You can't read anything about the physics, but I can show you 10 million successful flights in conditions like yours. Now you pick your spaceship. Trust through explainable AI is the first one. Trust through testing is the second one. So explainable AI, I don't recommend it for trust. Now what do I recommend it for? Analytics. If your goal is to improve on your spaceship, then understanding a little bit about it really helps. If you want to know what to develop next, if you want to see, where are some current failures so that we can do something better with it, then you need that approach. But it's just analytics all over again. And coming back to analytics as an area of data science, that has been around for as long as there has been data that we have looked at. So there is a long, decades-long discipline of excellence on how to do that. Explainable AI is just reinventing that wheel.
So what I'm taking away from this is that actually, before we get obsessed with explainable AI, which is a bit of a leap forward, we need to understand how we want to use it, how we should be using it, whether we're using it in the right way before we start to try and explain it to anybody else. So we now have a minute left. This time has flown by. What I'd like you to do really with that last minute is just give us, so if we're working in data-driven, increasingly data-driven organizations, just give us in a nutshell your best bit of advice for how we should be changing our thinking, creating our thinking, doing our thinking about the use of data in those organizations.
All right, well, this is a big one, and it's both uncontroversial and very controversial, because it's going to hurt. As a society, we do not behave as though good decision-making is a skill. We promote people on the basis of all kinds of things, and great things, perhaps how well they manage their people, inspire their organizations, their vision, but not necessarily their decision-making skills. And then we put them in positions of authority. Authority over very large technological systems that are going to affect a lot of lives, over massive decisions, like whether or not to release a pharmaceutical. And they may not have the skills to do the first bit that needs to be done before we can bring the technical nitty-gritty experts in. Those skills need to be taught, and we need to start taking seriously that those are skills that we need to muscle up on if we're going to do this, be in these positions of authority. And look, I'm not for firing the leaders if they don't have these skills themselves. Just recognize that somebody on the team has to help them. Somebody has to have the skills. Hire somebody to help you with your decision-making technique. We don't automatically become good decision makers because we're born that way. You're good because you practice. You're good because you try to improve yourself. You're good because you look for feedback and you try to do it better. And so if we're going to make better data-driven decisions, we need to be better decision makers. We're only going to do that with effort if we make ourselves do it.
Good advice. Thank you very much. Cassie Kozyrkov, you've been amazing. It's been a tour de force. I hope that's been useful. It certainly has for me. I've gone away thinking about data in a completely different way. Please show your appreciation for Cassie, and thank you very much for joining us.